in this video we're going to look at the first topic to do with hydrostatics, which is the new overall topic we're starting, and that's density and relative density. So you've come across density before, so there's nothing new here for you in terms of the equation, but the questions can be a little bit tricky and they require a little bit of practice. So hopefully from junior cert you remember that density, or the density of an object or a substance, is equal to its mass divided by its volume. And hopefully as well that you're starting to get used to getting units from an equation. So if density is mass divided by volume, the unit of density will be kilograms divided by meters cubed, or that's often written as kg per meter cubed, like this. Now density as well can be measured in grams per centimeters cubed, but in the last video we talked about SI units, so you might have to be able to convert between here and here in some questions. The symbol for density is a Greek letter, and it's kind of like a stretch D, and it's rho. That's how you pronounce it, rho. So we write density as rho equals m, a small m, over a capital V, because mass is a small m, but volume is a capital V. So without even knowing the equation, you should really try and just understand kind of variables by their units. So for example, if something had a density of 5 kilograms per meter cubed, what does that mean? Well, it means 1 meter cubed of it, and we could draw a meter cubed. It'd be 1 meter, a box 1 meter high by 1 meter wide by 1 meter deep, would have a mass of 5 kg. That's what it means. It means every 1 meter cubed of that substance has this mass. So if I asked you, well, how much would 5 meters cubed weigh? Well, it's not really weigh, but what would be the mass of 5 meters cubed? Well, if 1 meter cubed has a mass of 5, it would be 5 kg multiplied by 5 meters cubed, so it would be 25 kg. That would be the mass of 5 meters cubed. Sorry, this should be 5 kilograms per meter cubed. So therefore we can figure out that the overall mass of something is its density multiplied by its volume. If every meter cubed weighs 5 kg and you 5 meters cubed, then the overall mass would be 25 kg. So that's just rearranging the equation or solving the equation without actually looking at the equation. Now in this topic there's another term that you'll come to know, and that's relative density. And the actual equation for relative density, and relative density has a symbol S, small s, is the density of a substance divided by the density of water. Now water's density can vary depending on the temperature and depending on if there's any impurities added like salt and things like that. But generally the density of the water, and it's something that you need to learn, and this is the density of water that you will use in questions unless they specify another value, is 1000 kg per meter cubed. So really the relative density of something is its density divided by 1000. An example would be, and you don't really even need to know the equation, if let's say density of copper is 1175, it's obviously not, it's going to be bigger, 4175. The relative density of copper would be this number divided by 1000, so it would be 4.175. If the density of oil is 850, the relative density of oil would be 850 divided by the density of water, which is 0.85. Relative density has no units, and you use it in questions times, but I tend to just leave things as density. I just don't, I find it easier. So that's the basics that you need to know. Let's have a look at a quick question, and this question is in your Folan's book on page 162. And it's a very simple question now, but it's kind of the introduction to this topic. So we have 100 milliliters of water. So let's say water. And the volume they've given us is 100 milliliters. You might remember from junior cert that 1 millimeter is the same as 1 centimeters cubed. So 100 millimeters is the same as 1 centimeters cubed. It's mixed with treacle. Treacle is kind of like honey. and the volume of the treacle is 20 milliliters, which is 20 centimeters cubed, and the treacle has a relative density of 1.75. So ST for treacle is 1.75, and from that we can get the density of treacle. It's going to be 1750 from the equations we've just done. Calculate the relative density of the mixture. Now the other thing we know actually is we know the density of water already. That's something you have to learn. It's 1000 kilograms per meter cubed, and I should put kilograms per meter cubed here as well. So this is what we know. So if we want to get, so these two things are mixed together and it has a new substance, and what's the density of that substance? Well, the overall density will be the total mass when they're both added together divided by the total volume. So what we have to do is we have to use what they've given us to find the total mass and the total volume. So let's, first of all, we need to use SI units here. So we have 100 centimeters cubed. That's the same as 100 multiplied by 10 to the minus 6 meters cubed from the last video. So if we want to get the mass of the water, well, density equals mass divided by volume. So mass equals density multiplied by volume. So mass will be its density, which is 1000, multiplied by 100 times 10 to the minus 6. So the mass of the water works out as 0.1 kg. For the treacle, let's get the mass of the treacle. I'll put W here for water. Mass of the treacle will be its density times its volume, which will be 1750 multiplied by, we need to have its volume, in meters cubed, so that's going to be 20 times 10 to the minus 6 meters cubed from the last video we looked at that. So multiplied by 20 times 10 to the minus 6, and that gives you a mass of 0.035 kg. So now to get the total mass is going to be the mass of the water, which is 0.1 kg, plus the mass of the treacle, 0.035 kg, which is 0.135 kg. That's the total mass. And to get our overall density, we also need the total volume. You have it here. So total volume will be the volume of the water, which we've already figured out is 100 times 10 to the minus 6, plus the volume of the treacle, which we figured out is 20 times 10 to the minus 6, which is 120 times 10 to the minus 6. So then to get our final density, our density is total mass divided by total volume. So it's 0.135 divided by 120 times 10 to the minus 6, which equals 1125 kilograms per meter cubed. Now just going back to that question for a minute, it didn't ask for the overall density of the mixture, it asked for the relative density of the mixture. So what I figured out there is I figured out its actual density. So the last step, I'll put mixture, will I, for relative density of the mixture, is to find the relative density of the mixture, which is 1125 divided by 1000, which is 1.125. Now in your book on page 162, they do this in a slightly different way, so you can have a look at their way if you prefer, but that's the way I'd approach that question. Very quickly then, because if the video is too long it won't upload on YouTube, find the weight of water inside a bucket which is 35 centimeters high, has a smaller radius of 5 centimeters and a greater radius of 8 centimeters. So that shape, that bucket shape where you have kind of a larger radius at the top and a smaller radius circle at the bottom, is known as a frustrum. And it's a shape you've probably come across before, but you probably haven't really come across it too often. A frustrum, in your tables, there's an equation for its formula, and its formula is formula for its volume, and the formula for its volume is 1 over 3 pi times h, where h is its height, and they told us the height is 35 centimeters. Remember, put that in meters, 0.35 meters, times capital R squared plus capital R times small r plus small r squared. Now what the capital R stands for, and it's very clear in your tables, the capital R is the radius, the bigger radius, and the small r is the smaller radius. So in our case, the smaller radius is 0.05 meters, which is 5 centimeters, and the bigger radius in the question is going to be 0.08 centimeters. So if you use this equation, you can get the volume of the frustum, and it's done on page 163 of your book. I won't do it now because the video is getting too long, but when you type all those values in, you get an answer of 0.00473 meters cubed. So that's the shape of a bucket of frustum. Now the question was to find the weight of the water. Weight, we know, is equal to something's mass times its gravity. We know density equals mass divided by volume. Therefore mass equals density times volume. So if we sub this in here, we get an equation for weight which includes density, which is density times volume times g. The bucket is full of water, so the density of water is 1000, times the volume, which we just figured out, 0.00473, times gravity, which is 9.8, and that gives you an answer for the weight of the bucket is 46.354, sorry, pen's going a bit wonky, 4 newtons, and that's your answer.